Question 8, and this is the linear programming question, and our scenario for today is Jonathan is going to sell hats at a fete. He can make green hats and red hats, and he's going to use linear programming to determine the number of each colour hat that he should make. Okay, so X is red, Y is green. One of the constraints is that there must be at least 30 hats. Write down an inequality to do this, okay? So it means that the total number of hats has got to be at least 30, so bigger than or equal to 30. So we'll get the total number of hats is just X plus Y, so that must be bigger than or equal to 30. Two further constraints are those. Write down two more constraints which apply. Alright, so obviously the only things that they've told us in the thing is about there being at least 30 hats, okay? The other thing, ones we always have to put, and this is kind of just because we're solving them mathematically, is making sure that we don't have a negative number of hats, i.e. the number of the red hats and the green hats must be bigger than or equal to 0. So that's all it's looking for that one. Okay, we're now going to represent all of these constraints on diagram 1 in the answer book, and hence determine and label the feasible region, okay? So I'll start with the ones that they've given us. So I've got 2y plus x bigger than or equal to 40. So the line that I'm trying to plot is 2y plus x equals 40. So that is my first line that I'm going to do. Alright, for most of them, the easiest way to do it is to say, right, if x was 0, what would y be? If y was 0, what would x be? And then once you've got your 2 points, join them up. So if x was 0, I would get 2y is equal to 40, so that means y must be equal to 20, so I've got this coordinate here. And if y was 0, that would mean x is equal to 40, so I've got this coordinate here. Get a ruler, nice straight line, and join that up on there. Okay, because it's an inequality, I actually want 2y plus x to be bigger than 40. So pick a point and plug it into that inequality. So I'm going to pick 0, 0. If I put 0, 0 into this inequality, I would have 0 plus 0 is bigger than 40. Is 0 plus 0 bigger than 40? No, it's not. It's smaller than 40, so that's not true. So I don't want the origin, so I'm going to just get rid of these points there. Last thing, just label a line just to make sure that we've got that there. So that line is 2y plus x equals 40. Okay, the next constraint that I'm going to draw was the second one that they gave us, which was 2y minus x, and I'm going to put equals minus 30. Is that right? Yeah, 2y minus x equals minus 30. 2y minus x equals minus 30, like that. Okay, so let's start off. If x was 0, no, let's start off with y is 0. If y was 0, minus x equals minus 30, i.e. x is equal to 30, which is there on the x-axis. Okay, now what happens if you say if x was 0, you end up getting 2y is equal to minus 30, which means y is equal to minus 15. Now, obviously, I can't plot that on my graph because it only goes up to 0, so I need to pick another point for x, just a point that is on the graph, okay? So I'm going to go for 60. Let's pretend that x is equal to 60. That's going to give me that 2y minus 60 equals minus 30. That's going to be take minus 60 across, 2y equals 30, y is equal to 15. So I can find the point 60, 15, which is a lot easier to do for you guys than me, but that's going to be over there. Once you've got that, ruler, straight line, draw it so that it looks like that. Okay, then decide which side you want. If, again, you just choose a point that's on one side of the line, I'm going to pick the origin because I find that easiest. I want the 2y minus x to be bigger than the minus 30, so bigger than or equal to the minus 30. If I plug the origin into that, I would get 0 minus 0 bigger than or equal to minus 30. That is true, so I want the side that's got the origin on, so I shade out the other side, which is that one there. And like I say, you can sort of do that with any point, but the origin's an easy one to do. Alright, and then label a line, 2y minus x equals minus 30. Okay, then onto the constraint that we made, which was the x plus y is bigger than or equal to 30. So, again, I'm just going to do my working out up here as I'm going. So, x plus y equals 30. If x was 0, that would give me y is 30. If y was 0, that would give me x is 30, so that's going to be down there. Draw myself a line, and it's going to look like that. We want the x plus y to be bigger than or equal to 30. Oops. So that's still on lines. I'll get rid of them. Oh no, too far. What have I done? Press the wrong button. There we go, right. So x plus y needs to be bigger than or equal to 30. Plug in the origin. 0 plus 0 is not bigger than 30, so I don't want the origin, so I need to shade out this side over here. And lastly, just label a line. This is x plus y equals 30. The other two constraints, the x and the y being bigger than or equal to 0, that kind of takes care of itself in there, the different bits on there. Alright, so, so, didn't tick these off as I went. I did that bit, represent all the constraints in the answer book, hence determine and label the feasible region R. So, this is my thing, feasible region, there is with an R there. Right, okay, moving on. So, I am now trying to, I've done this bit. The cost of making a green hat is 3 times the cost of making a red hat. Jonathan wishes to minimize their total cost. Use the objective line to determine the number of red hats and the number of green hats, clearly drawing and labeling. Alright, so I'm trying to minimize the cost. This is part D. It's the cost that I am trying to minimize. I know it's going to be something X plus something Y, and I just need to figure out what they are, okay? Now, this one's been a little bit sticky because it's kind of not really giving us a price for each thing. It just tells us that the green hat is 3 times the cost of the red hat, okay? Now, the way I sort of think of it is say, right, well, if a red hat cost £1, that would mean the total amount of money I would get from red hats is just 1x or just X. Then the Y ones costs 3 times as much, so I need to times that one by 3. So I want the cost is equal to X plus 3y, because however many y's you make, you have to times that by 3 to see how much they cost to make. Is that the right way around? Yes. Okay. Yeah. Alright, so that is my objective function that I am trying to minimize. I need to use the ruler method, so I have to draw a line. So to draw a line, I need to make this equal to something. I'm going to pick, I want it to fit on my graph quite nicely, so I'm going to pick a decent number, and I want it to divide by 3, so that I'm not going to get awkward ones when I try and plot it. So my graph goes up to about 60, so I'll tell you what, 60 is a good one as I need to use. So I'm going to use, in fact no, I'm going to stick with 30, just make it a bit smaller. Okay, so if I want to plot that, if x was 0, that would mean that y is equal to 10, and if y was 0, that would mean that x is equal to 30. So they're my 2 coordinates that I need to plot on there. So back to the graph, I've got 0, 10, and I've got 30, 0, which ends up like that place again. I need to draw a line. I'm going to do a bit of a dotted line just so I can see the difference. So this is my line here. That is my objective line. In fact, I'm even going to draw that so that it's a bit longer. Right, so now I want to minimize, so I want the first one that this line touches as you slide it, the one that's closest to the origin, so it can just slide like this, and you can see that when I slide it, it's this point down here that it hits first, okay? Just put the line back to where it was. Obviously you're just doing that with your ruler, you can't pick up your line and move it, yeah. Anyway, so I'm looking for this point here. That point lies on the line 2y minus x equals minus 30, so 2y minus x equals minus 30, and it also lies on the line, this one here, 2y plus x equals 40. 2y plus x equals 40. Okay, solve those to find your x and your y. To solve this one, I could start by adding the 2 equations, which is going to give me 4y equals, x's would cancel out, is going to give me 10, therefore y is equal to 2.5. To solve for the x's, subtract the 2 equations, I'm going to do bottom take away top. That's going to give me 2x is equal to 70, x is equal to 35. Alright, I can't make 2.5 hats, so I need to round it. I'm just going to look at my graph to do it. It needs to stay in the feasible region when I round it, okay? So for this one, I'm going to have to round it up, because if I rounded it down, it wouldn't be in the feasible region anymore. So I'm actually going to make that y equal to 3. So that means he is going to make 35 red hats and 3 green hats. Okay, term the number of that. Excellent, so I've done that, tick that off. Alright, given that the minimum cost of making the hats is £107.50, determine the cost of making one green hat and one red hat, making your method clear. Alright, so let's go back to the number of hats that we have got, okay? We've got that we're going to make 35 red hats and 3 green hats, and altogether that comes to, that comes to £107.50. Now, we know the green hats cost 3 times as much as red hats to make, so this is the equivalent of making the 35 red hats plus 3 times 3, which is 9 of that, because the green hats are 3 times more expensive. Add that together, so the equivalent of making 44 red hats is, so 44x, what's my x is there, is equal to £107.50. So £107.50 divided by 44 will give me the cost of one red hat. So £107.50 divided by 44 gives me £2.44. We know that the green hats are 3 times as much as that, so times that by 3 to get a green hat, and that is £7.33, and that's just done on a calculator. So red and green. Go back to the question. There we go, and that is that question finished. Alright, sorry, I have just got one quick confession now, because I haven't quite done one bit of it right. If I just sort of go back, so I was fine up to the very end of part D, and what I did was I ended up rounding my y to get a 3. Once you've done that, actually, if you sort of go back to your graph, for this 3, which is there, you can actually see that the 34 is still in there. So because you've rounded the 2.5 up to the 3, you actually, I'm going to do my corrections in red just so you can see what bits I was talking rubbish at before. This 35 then actually rounds down to becomes x equals 34, because that's obviously going to cost less than it is to make 35 hats. So it shouldn't be 35 hats, it should be 34. That means that on this bit here, this should obviously be 34. This should then be 43. And then that just changes my prices slightly, because I want £107.50 divided by 43 now, which is £107.50 divided by 3. That gives me, divided by 33, 43, dearie me, divided by 43 gives me £2.50 for a red hat, so that should be £2.50, and that should be then £7.50, because it is twice as much. And like I said, there's apologies that I did miss that, you know, I would have lost a couple of marks in the exam there, so never mind. But because you've rounded the 2.5 up to the 3, then that means that you can round the 35 down to the 34, because then that point is still in the feasible region. So just be careful when you're checking sort of the values in that little area, to try a few of them out to get the different bits onto there. And that is now correct. Apologies for that amendment at the end.